In the last class we have seen HDFS, its theory concepts, and practically we have worked with HDFS. Now we will see with Hadoop, the initial Hadoop and later Hadoop 2.x. See, Hadoop 1.x has got only mainly two components, majorly HDFS and top of his words MR programs or a map reducing framework. In Hadoop 1, map reducing will be taking care of both cluster management, means is working as like a name node, means like a name node, and also it is also doing the same of data processing, so also doing the work of data processing. So it was become more burden on map reducing framework. It also, because it has to resource the management over the Hadoop cluster, and also it has to do the work of data processing. So in order to overcome this, they came with Hadoop 2.x. In Hadoop 2.x, the main core HDFS, and on top of that YARN came. YARN is called as Y for yet, A for another, R for resource negotiator. Negotiator means yet another resource negotiator. YARN takes the works of cluster resource management, means YARN is doing resource management over the Hadoop cluster, and on top of that MR programs were running for data processing, and it also supports for other components like Spark, etc. So Hadoop 2.x was increased with scalability also, means scalability in the sense, before scalability was increased. Before, one system was connected to number of nodes, and the burden over single master node, because it was doing both data resource cluster resource management and also data processing. But now there is another YARN, and this is YARN, this is MR, and YARN was connected to MR, and YARN was doing resource management. This is HDFS systems. So the scalability was increased. I will show you in one more picture, right? See, this is Hadoop 1.x, and this is with this whole was with 2.x. In 2.x, in 1.x, there is only map reducing. This is master node, and this is slave node. The clients were some Hive or MapReduce programs This master node has name node as job tracker, means what are the where and all the jobs are assigned, and this task tracker under the slaves contains information on data node. But in 2.x the MR was this MR was splitted into, means the job of MR, they process the data, and the star management was splitted between MR to data processing and YARN for resource management over the cluster. So in here the job tracker was replaced to resource manager. This is master, and the task tracker was splitted to application master and container. Means task tracker was now called as node manager. Container is the place where execution of data was doing. It's a place where execution was going on. So this is how the burden of MR in Hadoop 1.x was taken by YARN in Hadoop 2.x. Now we will see what are the things you have to learn for MR. Now we will see how why map reducing is required. We'll see why MR. We already know with scale up and scale down. We know scale up and scale down architecture, how these two are helpful. So for scale down architecture we need to use MapReducing framework, MapReducing technique to achieve scale downing. So Hadoop uses scale down architecture, and so it also connects with MapReducing. So now we will see how it works, how MapReducing works. MapReduce means MapReducing, how it works. MapReducing has two classes, means two set of programs. One is mapper and another is reducer. MapReducing will work with keys and value pairs. So in mapper class the program will make key value pair and this will be given to reducer, and reducer combines key value pair to give an output. So input will be given to mapper, and mapper will do key value pair, and key value pair is given to reducer has to combine the key value pair and gives an output. We can also add, it's completely optional, partitioners program in between MapReducing, because partitioner will routes the data from mapper to resources. It's completely optional. We can add it, or you can also do only with mapper and reducer. Now we'll see with an example. See, there is a one big input file. See, deer beer river, car river, deer car beer. This input file was splitted to partition along the cluster, along the racks, to deer beer river, car river. So there are 3 systems, or means 3 nodes. Also there will be 3 mappers. If you have 4 nodes, there will be 4 mappers. Okay, these mapper makes the key value pair. See, deer will be key, and value of deer will be 1, beer will be key 1, river will be key 1. See, same here, car key value 1. It will make key value pair. Mapper will make key value pair. This is how MR works. How it works. And after that, shuffling and also sorting will be done. That from all these clusters of data, see, the first beer will be considered. Beer is here, it will go here, and there is one more beer is also here, it will also go there, and it will make convert into one cluster. Then we will take with car is here, it will go here, car is here, it will go here, and one more car from third rack will go here, and deer from first rack and deer from third rack will go here, and river from first rack and river from second rack will go here, and saves with key value pair. And reducer combines the key value pair to form the output. See, 1 it will combine to so with k with v and k with v combines to form k of v plus v gives some kv new view value. So beer it gives 2, car it gives 2, deer it gives 2, and river it gives 2. So, and it gives the output here. So in output what we got the count of those words. In the input file we got the count of those words in the file. So there will be 2 number of words in this file and three times car is appeared, two times beer is appear, and two times river is appear in this file. See, this is how map reducing will work in the counting the words example. We'll see with another example. We'll see with the salary thing. See, there's a big company. It has so much of data, and it is the information about the employees is stored in a distributed system. Okay, this is one system, one more, and information like it's a here, there will be a B here, is C here, D here, here it is E, F, G, H, I, J. These are the employees. He gets 2k salary, means 2000 salary. He gets 3000 salary. This guy will get 4000 salary, and this guy will say 6000, and this one will get 8, 9, 10. I mean, you will get some 4k, this H guy, and this guy will get some 15k salary, and this guy will get some 3k salary. These are all input files. And this is given to mapper. Mapper there will be four mappers, 1, 2, 3, 4. Mapper will gets the highest salary from this node. This will be 3k, and here it will be 6k, and here it is 10k, and here it is 15. No, this is 15k. So, and it gives it to reducer class. What reducer will do? Reducer will check all this, and it will get the 15,000 is the greatest highest salary for I person, and this is the output is highest salary 15k for person by name I. Okay, this is how map reducing will work. Now we will see what are the advantages of using MR. Advantage first, with cost effective, means it is cheaper, cost effective, because we have already see that scale down, because Hadoop uses scale down architecture. In scale down architecture, the cost is reduced, because instead of using multiple supercomputer, we use normal computer of generic use. So this will be cost effective. And second one more is the processing will be fast, because we do parallel processing over the distributed file system, because parallel processing it works fastly. Then you can provide security also by giving a permission like read permission, write permission, and execute permission using chmod and others. Also provides security and provides flexibility. flexibility, because MapReducing program can be implemented using any languages like Java, Python, R, and it also can save. It can also save all types of data, all types of files like text, JPG, videos like MP4, MP3, MKB. These are all the main advantage of using MR, map reducing. Now, before Hadoop 1 came, after that they introduced YARN. Yet another resource negotiator is called Hadoop 2.x. What's this? 1.x. Now 2.x. Now in the last year we got with Hadoop 3.x. Now we have Hadoop 3.x. It's the latest version. Hadoop 3.x. There is no such architecture difference in Hadoop 3.x, but there are some improvement as given with Hadoop. First, HDFS was consuming 200% of the space in 2.x, but now it is only 50% of the space, and it is now Java 7 to Java 8. It can be extended, and the scalability was increased. Scalability increased. And the file system means the storage system. Now it supports all types of storage system, even now it is supporting for Microsoft Azure also. And before, under one cluster was supporting only up to 10,000 nodes, but in Hadoop 3, under one cluster is supporting more than 10k, means 10,000. More than 10,000 nodes are supporting. And this is last but not the least, the main thing, before the fault tolerance was using by replication. Means I told you, this one piece of file is stored in 3 different nodes. Replication. 3 different nodes. If one node is failed, the master node used to fetch the same file from other available nodes. This was time consuming, more time consuming. So now they replaced it with now Erasure coding. Erasure coding. This is the main feature of Hadoop 3.x. The fault tolerance was used with replication thing in Hadoop 3 2.x. Now it was more time consuming, it was more slow, so they used erasure coding. Now the technique was changed. And what is erasure coding, how it works, we will see in the next class. And in the next class we also do some practical works. Okay, thank you for now. In this class we have learned the difference between Hadoop 1.x, 2.x and 3.x, and what is YARN, and how MR works and its advantage, everything. Thank you. Bye bye.